Hello everyone, welcome back to yet another UniRC 7 Pro video, but in this one I'm going to dive deeper into the more advanced functions of the radio, which makes it really stand out from the competition, how to get them working, and also some neat little tricks and details about it. Before we dive into it though, I would like to urge you to consider becoming a channel member. In addition to helping support my work here, you will also get some perks in the process, including early access to videos, so make sure to check it out. Also, some of you might notice a change, hopefully for the better, in the audio quality in this video compared to everything that has come before it. I am constantly looking for ways to improve the end results of my efforts, and addressing the audio quality is something I had been postponing for quite a while. Since I am using a new setup to record the audio starting with this video, please let me know if your ears are liking it better than before. But let's get on with it, shall we? Following the range test video, a few people asked about performance with directional antennas. Now, this is a tricky question when it comes to digital video systems. Intuitively, you would assume adding a directional high gain antenna to your setup should give you an increase in range. However, unlike analog video systems where this is generally how it works, digital systems work differently, and antenna directionality and gain are only parts of the equation. There is a lot more to them, mainly having to do with how they're programmed and set up to operate, and how they handle lost packets and timing factors. Back in the day when I was first testing the SIYI HM30 system, I had it set up in the 8km mode. No matter what antennas I put on the HM30 unit, it never got past the 8th kilometer. The video would cut off roughly around the 8th kilometer no matter what you do. So this is how it works. I asked SIYI about directional antennas, and they said that in theory they should help increase the range, or at the very least make it more robust up to its eventual hard limit, but they have never tested the system with directional antennas, so had no idea how much more range can be squeezed out of it. I guess further testing will be needed to help figure this out. I did also ask about the stock stick antennas and if they are special somehow. I did not get a clear-cut answer whether they are just regular Wi-Fi router antennas or a custom item, but they did say that they test all of these before shipping them out with the radios, so interpret that bit of information how you see fit. All I know is they seem to work pretty darn well in my first range test. The second thing that I feel needs clearing up are the wireless operating modes of the UniRC 7 system. The bitrate enhancement mode is aimed at providing you with the best image quality the system can muster, even if that is at the expense of some range, as it essentially doubles the data rate potential of the link. This would be useful in situations where you need to prioritize display image quality, for some reason, over distance. The standard mode, on the other hand, will try to maintain a balance between image quality and data rate capability. It will do its best to keep the set resolution coming through with the set frame rate, so will not degrade the image quality as distance increases, but will freeze here and there as the situation and environment factors warrant it. So it should provide a good balance between image quality and link range. The bitrate priority mode, however, would sacrifice image quality in an attempt to maintain frame rate and link stability. So it would make sense that this is the mode you would want to use for the longest distance. However, SIYI have told me that the standard mode should be the one used for long-range flights, and yet they are the ones that have provided these definitions of the operating modes to me, which obviously suggests that the bitrate priority mode might be the one to use for longest range. You all saw what the standard mode can do in the first range test video. I guess more testing will be needed between all the modes to get an idea how they really work. And speaking of modes and data rates, there is a clarification that I need to do here about the link status menu and the information it is showing. Turns out, what you can see in that menu is not the current amount of data being received from the Air module, but the potential maximum amount you can achieve at any given time. For me, it is weird to include only this metric without giving you an indication of what the current actual data rate is. This is all good and dandy, but not knowing what your system is actually putting through the wireless links makes the potential link data rate indicator very useless, because you don't really know how much of it you are using, so there is no way for you to judge how saturated your link's potential is. Like already mentioned in my initial overview of this system, I much prefer the way it is done on the SIYI FPV app, where it shows you the actual amount of data that is coming through the system. Ideally, show both and bring them out to the main view area of the app, where it will be quick and easy to judge how the link is doing without essentially blinding yourself to what is happening up there by having to go into the menu. Another thing I wanted to show you is how the manual channel switching works when you disable frequency hopping. So, you basically disable it. And then, when you click here, you will be given a choice between all the channels that the system can operate on, and you can select one manually. What is lacking here though is the ability to see how much interference there is on each of these, something that DJI have been doing for years on their drones, and I did suggest to see that it will be very useful if they can add that in a future app update. So I guess we have to wait and see if this will ever happen. But there is one more thing I want to show you here, so you can get an idea how you can judge how much interference there is on each channel. And even though it is a bit clunky as you have to move through the menu a lot, at least it works and it's useful. But I want to clarify something first, just in case at some point in the future a single flat earther gets tricked into watching this video and makes it all the way to the end without skipping 90% of it. Listen well, -60 is less than -40. Remember this for what is to come. So, for any given channel, you will be able to see the image strength indicator in the link status menu tab. Going through the channels, either manually or when the system frequency hops, you will notice that this indicator's value will change. You are looking for the highest possible value. Again, -40 is higher than -60, which will indicate that this channel suffers the least amount of interference. Lower values like -90 and below suggest a lot of crap happening on this channel, so not a good option to be there. During my range test, I saw values as low as -93, but it is expected for that value to lower as the range increases. I am not sure what it got to when the video's latency increased, hence why I really want to be able to see those indicators also showing on the OSD overlay or at the indicator bar at the top. So keep this in mind. Lower, worse, higher, better. Generally, the system will select the best channel automatically, but if, for some reason, you want to be on a specific channel without hopping, you can do it. And while we're still on the topic of the UniRC 7's video link, a few people have asked about link encryption and whether it exists in this system. I have asked SIYI about it, and they said, much to my surprise, that by default the link has a 128-bit AES encryption, which is pretty decent, I think. Upon request, they can update that to 256-bit AES encryption, but that also comes with an additional payment, though they claim so far nobody has asked for that. If you need a system with a higher level encryption, feel free to contact them directly and inquire about it. But let's get out of the unseen for a bit and turn to switches, which can be seen, touched and felt, and their programming options. In my initial overview, I did say that the 3-stage option for the push button acts like a 2-position switch, but that was wrong. And it turned out to be wrong when I actually sat down, dedicated the time, and read through the whole manual. Ha! Who would have thunk it? Reading the manual might actually be useful for once. So, as it turns out, the 3-stage option for the switches does give you 2 positions. Minimum and maximum are achieved by short pressing the button, so it will toggle between the 2 states. In order to get the 3rd state, the middle position, you have to press and hold the button for a bit and it will get to the middle position. This is pretty neat, but you will have to remember which buttons you've programmed for that, and also you cannot go to the max position from this one. It always reverts back to minimum and then you have to short press it again to get it to maximum. From maximum, the long press would also get you into middle position. Another fascinating bit of information, which I puzzled out of the manual of all places, is another option for the 3-button flight setup. In fact, it turns out that from the system menu, In addition to choosing which channels get the flight setup, you can also choose whether it uses 3 or 6 buttons, so basically either M1, M2 and M3, or also add M4, M5 and M6 to that, which would allow you to make full use of the 6 flight mode options given to you in the Flight Modes tab in Mission Planner, or other ground control station software for autopilot. This does show you how this system was indeed designed with a particular autopilot environment in mind. Not that there aren't any others, it will probably work with those just as well, but you know, generally you design for what works best and is most reliable. That being said, I am looking into the possibility of this system working well with the Mavlink output from an iNav flashed controller, and whether it will be able to properly interpret that telemetry stream for the OSD and the gimbal data fusion. A few people have asked about this system on iNav, so I will look into it and let you all know how this goes in a future video. Which reminds me, if you haven't already, do hit that subscribe button and consider also the bell, so you can get notified when new videos are out. But let's move on to the next bits. One thing which for me is a huge improvement in the UniRC GCS app over the SIYI FPV app is how it handles 2 video streams coming to it from the air unit. The SIYI FPV app would show you no information on the camera which is currently in the small window to the side, and the recording counter would constantly bug out and restart when you are swapping feeds. The UniRC GCS, on the other hand, does show you an indication that both cameras are connected, that both cameras are recording, and even though it does not show you a timer for each, it at least shows you they are both recording regardless of which one is on the main view. And get this, you can start the raw stream recording for each camera, and then when you swap between them, the stream recording will not stop, which is mighty awesome and shows the potential and the capabilities of the hardware of this radio, which certainly is higher than anything the MK series radios can muster. Pretty awesome stuff indeed. Now, in my initial overview of the UniRC 7 Pro, I did say that connecting the LAN port on the radio to your computer resulted in an unidentified network that would connect neither to telemetry nor video. And again, after reading the user manual, I figured out why. When using the cable, which is an option only to the Pro version, the non-Pro version of the radio does not have this port. You need to enter the IP addresses manually. In this case, the computer's IP address needs to be 192.168.144, and the last value is up to you. But to be safe and to make sure you don't interfere with some CE gear, use 100 and up. The mask will be auto-filled in, and for default gateway you need to enter 192.168.144.20, which is the UniRC 7 Pro's IP address, and it essentially manages the network. And voila! Moments later the network is no longer unidentified, and all of a sudden the UniRC GCS Windows app and Mission Planner can connect and load up video and telemetry. I am glad I got this working, and it will be useful in situations when you need to eliminate absolutely any possible chance of interference to give the wireless video link the best chance at range or some other performance metric. The LAN connection can also be used for other purposes, but that would depend on your purpose for this system. Next functionality on the list is the same connection but over the hotspot link. For some reason this puzzles some people and they wanted to know connection settings. On the side of the radio, you need to go to the Data Link subtab in the menu. There you can check which port is the UART option set to, Data 1 or Data 2. These correspond to the UART 1 and UART 2 ports on the air unit respectively. You have to either change to which data port is the UART assigned in the Data Link tab, or plug the telemetry cable from the autopilot to the relevant UART port on the air module. Then make sure the parameters in the autopilot related to its port, which is outputting telemetry, are set to Mavlink 2 as the protocol and 57K as the baud rate. In the Data Link tab, those should be the values by default. If not, adjust them accordingly to match what is set in the autopilot. Now, the manual instructs that what is set to UART actually needs to be UDP for everything to work over hotspot. However, in my case, everything seems to work very well when this is set to UART, so I am not touching it. From here, you only need to go into the hotspot settings, change the hotspot's name and password if you wish, and enable the hotspot. Next step is on your computer. You open the wireless networks list, and when the hotspot shows up, you connect to it and wait for the network to be identified with the name you've given it. Next step would be to open your ground control software of choice, but keep in mind that it would be better to close down the Radios app before connecting to the computer. If you want to use the Windows version of UniGCS, when you open it, the video feed will load automatically, but in order to get the telemetry, you will need to connect it manually. In the top right corner, you will need to select UDP from the drop-down menu and then change the last digits of the IP address to 20, just in case they are not that, which is the correct one for the UniRC 7 Pro. I would assume it is the same for the non-Pro model as well. Port should remain untouched and click the chain button to the right. If all is good, it should connect and the OSD will show up and you will be able to see the data on it updating. From here, you can do pretty much the same things you can on the Radios UniGCS, although at the time of making this video, the Windows version is lacking a few options, but nothing major, and all of those will be added soon. Or at least so SIYI promises. Alternatively to UniGCS, you can use QGround Control or Mission Planner, but since I'm not a fan of QGround Control and don't use it, I will show you how to connect Mission Planner. Open the program. From the connection drop-down, select UDPCI and click Connect. Enter the IP address, which should be 192.168.144.20. Click OK, then enter the port number, which should be 19856, and click OK. And if all else is good, it should start loading the parameters shortly. Now you can load up the video feed here as well. It is a bit trickier, but let's get through it anyway. Right-click on the HUD, and from the drop-down menu go to Video and then Set GStreamer Source. This will open a window to enter the RTSP stream address, but this is too long to dictate here, so I will have it pasted in the video description below. By default, all SIYI cameras and gimbals come with the same IP address, which is 192.168.144.25. Since I have two cameras on my system, I had to change the IP address of the gimbal since it is easier to do, hence in my case the IP address ends in 26. You can copy this text to your Mission Planner, but keep in mind that the stream name might also vary between gimbals, so check with your gimbal's user manual before trying it. For the ZR10, the stream name is main.264. For other gimbals, it can be different. All the remaining info should be the same. Click OK, and in a bit, if all is good, the video feed will load. You can then right-click and select Swap with Map to bring that to the right and make it bigger. The only drawback of using the video in Mission Planner is the fact that you don't get the gimbal control by using the mouse like you do in UniGCS. However, unlike UniGCS, you can have video feed in both Mission Planner and in the Radios UniGCS app at the same time with no obvious increase in latency or decrease in video quality. But you will need to have telemetry either in the app or in Mission Planner. It will not work for both at the same time unless you connect a second telemetry port from your autopilot to the other UART port on the air unit. In such a case, you can connect to it from the computer via the Bluetooth module, but make sure you pair to the Bluetooth device with the name starting with blue. The pairing will create a virtual COM port over Bluetooth, so in Mission Planner you can select that one. It will be different for everyone. In my case it is COM18, and speed should match whatever is in the Data Link tab under the Bluetooth connection mode. In my case it is 57K. If all else is good, it will load the telemetry, and now, since Mission Planner can also display the video together with the Radios app, since the telemetry for each is coming from a separate port, they will both work and won't interfere with each other. So in essence, you will have both video and telemetry on both Mission Planner and the Radios UniGCS app with full functionality on either, which is a pretty darn nice thing that the UniRC 7 can do, and this particular functionality will work on both the Pro and non-Pro versions. Now, just in case there might be concerns that using the hotspot might affect the radio's range, I have recently discovered that you can choose the frequency on which the hotspot will run, so you can switch it to the 5.8 GHz option, which should not interfere with the 2.4 GHz module on the radio, which is supposed to be the one giving you the longest range. So the lack of a physical LAN port on the non-Pro version might not be that big of a deal if it all works interference-free over a 5.8 GHz hotspot. One more thing that I wanted to talk about is the potential capability that this system brings to the table in terms of connectivity and custom gear. Essentially, the HM30 system and apparently also the UniRC 7 system are wireless local networks. Not so local when you consider the range, but in essence they're just wireless networks with IP cameras and devices connected to them. With the UniRC 7's air units having two LAN ports on them, you have the option to either connect two cameras or have one camera, and then the second port, which is essentially a network switch, can have something else connected to it. The FPV hub, for instance, which will give you two more LAN ports, or some piece of research or testing equipment, which from the ground can be accessed, like you saw above, over a LAN cable or a Wi-Fi hotspot network just by setting its IP address accordingly. So essentially this system provides the capability to connect to, control and receive information from any form of equipment you can put on a drone, so long as it can be given an IP address so that it can become accessible over the network. I find the prospects of this highly intriguing and the potential for research and testing actually quite unlimited and also quite convenient. But I will have to call it quits here, as this video has turned into quite the hog already. If you have liked it and found it useful, give it a thumbs up and share it, and if you haven't already, subscribe and notify so you never miss an upload. A huge thank you to all my members, my Patreon supporters and anyone who has supported this channel in any way. Safe flying, and I will see you in the next one.